And then our last session will be a closing roundtable with several of the speakers from the conference. So with that, I'll turn it over to Bashir.
Okay, thanks, Arjun. Hi, everyone. I am Bashir. Hopefully, you can see my screen.
Yep, we can see it.
Yeah, cool. Yeah. Okay, yeah. Like Arjun said, I am Bashir. I'll try to go a little bit faster, and maybe we won't have much time for QA, but I'll check the QA after, and we'll answer in the QA chat. So this is an extended version of my talk in DevDays in June. And the link is up there. So if you want to follow, you can follow this link. And I'll try to go the earlier slides a little bit faster because it's just like a repeat of what view definition is and things like that. Yeah, I have been in Google for over 15 years and most of it around, data engineering and things like that. And the last like 5 years, 6 years, healthcare data. So this is about Open Health Stack. So I'll focus on one of the components of Open Health Stack, but in general, Open Health Stack is a set of open source components that my team create, and everything is in GitHub. The development process is also open. There are tools for creating, client-side FHIR-based apps, like on an Android phone, for example. There is like a gateway for implementing security and access control. And there is FHIR data pipes, which is the focus of my talk today here. So this one, like last year, I also showed this slide, and this is basically the general diagram of how the FHIR data pipes actually work. So basically, the idea is that we want to convert the FHIR data into a format that is easier and faster to run analytics queries, like population level type of queries. So basically, we have these pipelines in the middle. They listen to changes in a FHIR server, and then it converts it to a quote unquote a data warehouse, which could be, we try to support different technologies. And then the downstream data processing can happen on top of that data warehouse. So we always had this idea that there should be, this is actually even like before this view definition was a standard, that there should be like a view layer such that we can hide the complexities of different data warehouses into that view layer, and then the downstream, like dashboards and measures and whatever are built on top of those views. And then this collaborative was formed, and then there was this SQL-on-FHIR standard and the view definition. So everything was great. So we implemented that in FHIR data pipes. I'll skip this. These are basically talks about why this is important, and the complexities of flattening that with different SQL dialects and SQL engines. I think John also talked about this yesterday, and others also have good talks yesterday. So I'll skip these. It basically talks about flattening and how it works. But the basic idea is that FHIR is a complex structure basically, and it's hard to write SQL against it. So let's flattening and then write simple SQL against FHIR. Now, why this is important in the context of text to SQL? So the goal is that we want to basically the eventual goal is that we want someone to come to a FHIR server and then ask a natural language question, and then they get the answer for it. The approach that we are taking here, especially like for population level type of queries, I'll talk a little bit about single patient type of query, population level type of query, to basically, you can you should basically extract some. Our goal is to convert the natural language query to SQL, and then we run that SQL on top of it. So there's a lot of work done on text to SQL. Again, I'm not going to go into the details of it. There's actually a very live, kind of contest between different approaches. And the work that, we have done here is based on these two frameworks, like Chase SQL and SQL Palm, which are, two of the participants in this competition, and they are in Google Cloud. So it's basically many of the ideas actually come from. So the components of this text to SQL approach is, so the first thing which is relevant to SQL on FHIR and this conference very much is that we built everything on top of SQL on FHIR, like on view definition, like flat views basically. And we tried doing something similar on the, so I skipped this in before that. We actually use the version 1 of SQL on FHIR, which is basically, it tries to be lossless. So we have the wide schema. So we call that wide schema. So with everything that is in FHIR, I mean, you can't be completely lossless because of recursive structures, but we try to be as lossless as possible. So we tried to build something similar, like over 2 years ago on the wide schema, meaning that, convert the natural language query into like SQL on the wide schema. And it didn't work very well. Now, since 2 years ago, the models, like, the language models have improved significantly. So maybe if we try again, maybe it's a different results. Also, another approach that can be tried, and we didn't try it back then, is that to teach the model about the different the dialect basically that you are using. So it could be like a few shot type of, you can put it in the prompt, or maybe you can even fine-tune a model, and then it actually works for the SQL engine that you have. But those are the things that we haven't done. We rely on the flat views generated by SQL on FHIR. So we feed the schema to the language model. We have a column sampling. So from each column that is in the schema, we sample some of the values. And then maybe the most important part of the whole thing is to basically to have a value selection type of a value selection kind of algorithm basically, or a method to help the language model decide which fields are actually relevant, or which values are relevant to this natural language query. And then we have a feedback loop to actually improve the query. So I'll talk about each of these in turn. So the first one is just, on the top right, you see the schema of one sample, flat patient table. And then there is, so originally we only were sampling 10,000 rows just to make the whole thing more efficient. But then we realized for some of the queries that I will show later that it's actually important to sample the whole thing and then pick the top, the most frequent one, and then feed that into the context. So all of these pieces are actually creating the context that we have. Okay, now for the selecting the concepts and the terminologies and stuff like that. So what we have done is that we basically go through the whole FHIR server, every FHIR resource that's there. And then we extract the codes and the terminologies that are in there. And then we embed them into a multidimensional space using this. And it could be, any model, any embedding model. But for this work, we have used this Gecko model, which I think it's embedded in a 700 something dimension space. And for this work, we have used the display text of each code. Now, this work is based on Mimic, and I don't think that, in Mimic, it's, you have a standard codes. If we had standard codes, I mean, at least many of the codes are not the standards. There are some long codes and stuff. But if all of the codes were standard, then maybe we could use the description of the code and then using that. But in this case, we are just using the display element of it. And then we have in this case, we are using, Postgres, vector support. And then when there is a query, then we find the terms that are close to that query. So in this, I have a running example that I will talk about it. So it's about, oxygen saturation in blood. And so in this case, so we have the three terms that are relevant to that query are O2 saturation, pulse oximetry, arterial O2 saturation, and oxygen saturation. So these three are basically embedded in a space. And then for my query, there are some concepts that are close to these, and then these are actually written. The entity recognition is done by this library, this Stanza library, which is again, well known in the NLP space. And we are using the biomedical and clinical package of it. So this is one example, and I'll talk more about this example. But in this example, I'm just showing that the entities that are extracted by this package. So the blood oxygen level is one entity, the pulse oximeter, SpO2, arterial blood gas, ABG test, and so on. So these components are extracted, and these are the ones that are used as query to find the close terminologies. So this is a picture of everything together, everything that's basically fed to the model. Obviously, we have the actual natural language query as well, but we have everything else as well. So in this case, I am using the Gemini 2.0 Flash model, but anything, any model, any language model can be used, especially if it's through Vertex AI, then it's actually very simple to fill. And by the way, everything that I talk about here is open source, and you can actually find the link. The links are also in the slides, so you can find everything there. But you can use any kind of language model that you want. Yeah, and then we have like an iteration step, which basically we get that query, that SQL query that is generated by the model, and then we run it on the actual data warehouse, and then we return the results to the model again, and then we basically expand the context, and then that query and the results is also there. If there is an error or something, that will be fed back to the model, and then it tries a few times until it gets like quote unquote correct query. There are other things that needs to be done that we haven't done yet, but if there are multiple queries that are they have similar results, and it should be some clustering done on them and things like that, which we haven't done. Okay, now more on the actual data set that is used for this evaluation. So this is built on top of the Mimic 4 dataset. And John again talked about it yesterday, that there was a conversion to FHIR, and there is also like a paper, like the SQL-on-FHIR paper, which uses the same example done on the FHIR version of Mimic 4. So we built on top of that. So that's actually a great FHIR dataset with real data to actually experiment with. So in these data sets, now I talk about these numbers because these are relevant to the core of the FHIR data pipes and the performance that we get there by converting the FHIR resources into Parquet and then use the Spark to query those. So everything that I will talk about is done on a single machine, but like a good machine. So there are 300,000 patients in the data sets, around 1 million encounters. And so you will see that, for some of these, you will get more flat rows because you may have some. Is my sound good? There seems that some people are.
I hear you okay.
Okay, okay, cool.
Yep.
Yeah. So just I continue then. Yeah, then some of the tables have more rows than FHIR resources because we have the flattening. So there are close to 500 million like observations, conditions, and so on. So this is the data set that we have. And like I said, this is based on the paper that John talked about yesterday, about the SQL-on-FHIR paper. And that paper was based on this other paper, which is like a kind of a clinical study about the impact of race on the oxygen saturation, especially when it's measured with pulse oximeter. So those details, we don't get to. We just want to replicate that, work with natural language queries. So we want to see that we can just tell what we want, and then we get the answer. So like I said, everything is open source, and the notebook that I show some snapshots of it is also open source on GitHub. So first I start with this query, and I said, so I dive into several queries because I want to actually show some of the limitations that we face when we do this kind of approach. So in this case, I'm saying that for patients that had their blood oxygen level measured both through pulse oximeter and ABG test, in the same encounter, count the number that are more than 2% difference. So the two methods have more than 2% difference. So this query is intentionally a little bit vague. And then what the LLM does, actually, to be honest, I was actually amazed with the ability of the language model to produce very, very good SQL. So I am a little bit skeptical in general about LLM, but this part was actually pretty good. So it can actually turn natural language query into SQL if the schema is not very complex. It actually does a very good job. So in this case, it actually has translated my query into something, but it's not exactly what I meant. But it's actually, if you if you read the query, the natural language query, it's actually correct in some sense. So it's basically what it does is that it's counting the observation pairs that are in the same encounter, and that the difference is more than 2%. So that's not what I meant, but my natural language query is not actually very accurate. So a couple of points here is that, so one is that, so it runs this query 5 times, and it has multiple joins actually it has large joins in each of those, and it does it 5 times, and the whole thing for the whole data set actually takes 50 seconds. And this is actually important because the LLM needs to be able to kind of experiment, run something and then get some results. Maybe it gets 0 or gets an error or something, and it needs to try that again. So now I try to actually make the query a little bit more accurate. I say that find encounters, and then in each encounter find the average of the 2 methods, and then if the difference is more than 2%, then count that. So it actually does the grouping again. Well, now it starts the issues with the codes, and I will talk about this a little bit in the next slides. So the codes, one of them is actually here is correct, the other one is incorrect. And then this is another version of the query, which is actually my goal. I just want to find actually the number of patients. So if for someone this has happened in multiple encounters, I actually want to count them one. So I'm saying that count the number of patients that have this, in the same encounter, they have this issue. And again, it does well in terms of the general structure of the query. There are, in this case, there were some issues with using the wrong date function, which was coming from, I guess, Postgres, but this was a Spark, and then it could correct that and things like that. And then sometimes it does an extra patient table join, which is not needed because patient IDs are in the encounter and observation tables. And these are minor points, but let's talk more about the codes. So let's skip this as well. Okay, so the first code, which is for pulse oximeter, actually is correct. And when I say correct, I'm comparing with the results that came from those other papers. So the code that those other papers were actually using. So in that case, this is 220277 is the right code, and you can see this is what is on the bottom. This is what is fed to the model. And that is basically saying that, everything that is close to the blood oxygen level. So, and we have the pulse oximeter here. And you see that at the bottom for the pulse oximeter, it's actually picked the right one. The problem comes with the, arterial O2 level or ABG test, for example. And the core problem is that this is the one that needs to be used. 50817 is the one that needs to be used. But if you look at the display of it, it just says oxygen saturation, while the other one is actually saying, arterial O2 saturation. So in some sense, this looks more correct than the other one. So I wouldn't blame the LLM, but I suppose when you deal with real data, these are the issues that you may deal with, that there might be issues with the codes and things like that. So let me skip this a little bit faster and then go to some takeaways and a few more examples. Maybe I cover one more example because I want to finish a little bit earlier. So doing SQL on flat views, it's actually much easier than the wide schema. I guess this is the the second point is the core question that everybody who works in this space needs to think about. That are we actually targeting developers or, let's say, practitioners or clinicians and things like that? And I mean, for developers, these kind of approach is actually great, and it just speed up the process significantly. But I don't know whether you can get all of, especially in the healthcare space, you can get all of the edge cases basically correct with just automatically with an LLM. I don't know. I talked about code selection issues and the importance of performance. And the last point is that everything that we were talking about was about population level type of queries, analytics queries. If we were doing single patient queries, then we had the option of feeding everything everything about that patient actually into the context, or maybe just select something. So basically feed FHIR resources directly to the context. I'll talk about that a little bit at the very end. But let's go to one more example. these are the things that I want to talk about this benchmark because this is important. So there is this EHRSQL benchmark, which is on top of Mimic 4 again, and that's basically to evaluate these kind of systems. Now the benchmark was built on original schema of Mimic, which is something else, like a flat schema, something else. It's not FHIR, but I have used examples from that to do it on top of FHIR version of Mimic. So the examples are coming from there. So these are some of the queries that I have tried here. I'll probably just go into details of one of them, which is fairly simple. The topmost frequent lab test, it actually simply does that. It's actually fairly simple. Maybe I do one more. Oh yeah, and then one of the reasons that I can't do this with I can't just do like a benchmark run is, first of all, it's just on the demo data, the answers. And the other one is that they have done some shifts in the dates. So the dates are different from what is it in the actual Mimic, and they have reasons for doing that. But again, for this example as well, that I'm saying, I'm counting the most frequent microbiology tests that are done for the people who are diagnosed with cardiac arrest in the same hospital encounter. So it's a fairly complex one, but again, in this case, it actually does a good job and actually can do that. I have other examples that it actually is not that successful, especially this one, which is a very hard query. And then for this one, it actually fails. So yeah, let's me then finish with just one last note that, so this is more kind of like, my recent focus and some of the more recent developments. So there are these two benchmarks. So the first one, like FHIR agent bench, is based on EHRSQL, but it's more focused on single patient scenario that I talked about. And there are also open weight models that we can try. This is actually something that I have recently started to help the team to better work with EHR data. So the MedGemma is an open weight model, and it can freely be used. And so the idea is that it's more tuned into healthcare kind of problems, so it can do better in those spaces. Sorry, I went a little bit too fast because I wanted to finish early, and I will answer the questions on the chat. Arjun, I don't know if you have time for QA or not.
Probably not this time around, but thank you very much, Bashir. Yeah, really interesting work, and your work with the Google AI teams, and particularly something like MedGemma, which I've seen. I think that's really exciting and useful for the audience to know about. There are these open weight models specifically tuned for medical data, MedGemma obviously being one of them. I think it's really interesting how we might apply them to our space. So really excited to see how this work continues to develop. And please reach out to the group and Bashir for more information. I know we packed a lot into a short time.